Hi there. Okay, this is just a 101 overview of what the AI revolution is and how it factors into the app. I'm going to do the best I can here. So, the key innovation that is driving the entire AI boom, what we're calling AI right now, is the ability for computers to understand written language and reason, meaning use some logic, reason-based, I haven't written in a while, on the written language. And that's kind of, in other words, to hear what is in that written language, to understand what you're trying to say in that written language, and then to write back in written language. That innovation is called large language models. Okay? That's what that means. They've used machine learning to learn, just iterate over and over and over again through tons and tons of data to understand how the English language works, for example. To understand what you wrote and then to write back based on the knowledge base that it has. And so it does have a big knowledge base that's just scanned from the internet of what's out in the world, all the knowledge in the world, all the serial numbers for the utilities in your house, all the, the specs for the tires in your car, all this kind of stuff. Okay, so that's the key innovation. The way that this is used the most often today, the kind of bandwagon that everybody is using to implement this, to put it to use, is the Copilot model. So a Copilot is just executing this step by step in order as a chatbot. What that means is you enter in something over here, like F-150 tire size, ? It's a query. And that can be full sentences. It can be all the way down to, just rows and rows of table data, just pasted straight in there as plain text like that. And so it's going to understand that, and then it's going to go out and into its domain of knowledge, its knowledge base, its memory, and pull out a whole bunch of information, and then it's going to write back an answer kind of like this. And let's say it's 270 by R, I can't remember how these work, 17, something or other. That's it. That's the full loop, right? Understand, reason, write back. So what I have done is extended this a little bit to add in another step. I'm using the LLM to understand. Well, let me just get rid of this. I'm using the LLM to understand what is written, right? This part. To understand it, and then what it does is it goes, after that, it goes to a database that contains all of the Bowen literature. It's a Bowen database, BDB. It's got all of the Bowen literature in it. And instead of going out for step 2 and using all of the information that the LLM model has been trained on from the internet, like when you go to ChatGPT, it has a general knowledge base of information available on the internet. All of the chatbots basically have that. Instead of drawing from that information, I am having it only draw from the Bowen literature. Okay? So then it finds from the Bowen literature a set of matches that are the closest match to the query. Here, let's say, instead of, here's my little chat window. Instead of the tire size, I'm saying, what is a triangle? ? So it goes out and it searches through all of that literature, which is actually a very easy thing for computer software to do. And it pulls out some matches, a subset, a very small set actually, like 5 to 50 or 20. That's something you can tune. Matches from the literature, paragraphs, let's say. And then the LLM returns a response only based on those returned passages. So a triangle is blah, 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 blah. So the reason I'm using this database that only contains the Bowen literature is the first place where we start getting into some really nuanced and conceptual areas. Okay, so I'm going to do my best to explain this. The state of the art in Bowen theory is that there are no statistical models to very precisely predict outcomes to precisely identify or diagnose a problem in a family, and to very precisely predict how a certain intervention will alter that problem and make it better, will solve the problem. We have very precise mathematical models, which is the essence of science, despite what a lot of people in the behavioral health field want to believe, and also in the Bowen network. Science is explicit modeling. You've got to prove a hypothesis, or you've got to test a hypothesis formally. And formal means essentially mathematics. There's exceptions to that, but so the state of the art in Bowen theory is that there are none of those, right? We don't have a formal model that tests hypotheses for a family based on interview data, for example. All we have is a conceptual model, right? So the conceptual model is derived from the literature. The conceptual model is in the literature. And that's something that is not super easy to explain to somebody who hasn't done, a lot of truly scientific research, like a master's of science or a PhD level science, a thesis, where you're actually building models, okay, and using data to construct models. It just means that when the coach, it just means that the state of the art, the model that's being executed, the rules, the algorithm that actually makes decisions, that evaluates a family and determines what the course of actions would be and their outcomes, make the predictions, that is in the coach's head. That is the state of the art. The brain literally uses concepts to run models, right? That's the material that the brain uses. It's conceptual. It uses logic and it kind of goes through and tries to figure out, it just runs the model based on what it knows about the family. In order to have a coherent conceptual model in your head, coherent meaning it actually makes sense, it doesn't conflict with itself, you've got to do a lot of training, you've got to read a lot of research, and it takes a lot of time and interaction with others actually too, so that over time you sculpt your conceptual model that you act out in practice. We don't have a mathematical version of that. You can't just type in a bunch of data and have a computer spit out an answer like you can with, how will this pain medication, how long will it last and what will the side effects be and all this kind of stuff. It's not precise like that. So the state of the art is conceptual, and it requires understanding all of that literature. The current way that we have to test whether somebody has a good enough conceptual model is in interaction with others. When you use certain words that don't make sense to others, or case presentations don't go anywhere, they don't understand what you're talking about, or you haven't learned to speak the language with your peers that are well trained, then that just means that your model needs more work. You need more training. You need to get used to the lingo and that kind of thing. There's nothing wrong with that. It's just that it's a very low resolution, low detail way to be scientific. That model is not very detailed. It makes a lot of mistakes. It's like a really low resolution image on a computer, 10 by 10 pixels instead of 10 million by 10 million, which is what you get with mathematics when they're accurate enough. Okay, so the state of the art is a conceptual model. The conceptual model, luckily for Bowen theory, essentially exists in the literature. But it's not in one place written out in a single thread, from start to finish. It's scattered throughout the literature. You have to take the aggregate of the literature and you have to have it all in your head. So I'm saying, luckily, with Bowen theory, the conceptual model is coherent in the literature, meaning there is a remarkable amount of consistency in the Bowen literature, and you can, I believe, derive a lot of the conceptual model from the literature itself. You don't need to have the person-to-person interaction as much as you do in another tradition, like, let's say, Jung's analytical psychology. That is a lot vaguer and the literature is all over the place. But Bowen theory has a remarkable amount of internal consistency. It doesn't conflict with itself much. You can kind of pull a model. As long as you can remember it all, you can get a lot of it from the literature. I know that because that's what I did. In my dissertation, because I'm obsessive with this kind of stuff and I was interested enough, I read all of the seminal literature line by line multiple times and mapped it all out. And that's how you end up with a theoretical dissertation. That's 1,000 pages. And I'm not saying that to toot my own horn. I'm saying that because it is. I know that it is possible to go through. I know that the literature is coherent enough with itself because I took what I read and I kept it all in my head, the result of that project, and I actually entered into the Bowen network and people understood what I was talking about and I was able to speak the lingo at an incredibly fast rate. So the literature is a good model for the state of the art of Bowen theory. Bowen theory is not terribly precise, but at least there's a possibility of extracting the model from the literature. Okay, so this was a long aside. How that factors into what I have on screen here is that Bowen database in the upper right, that's the literature, right? And now that we have LLMs, the LLM can read all of that literature and understand it all, and it basically has the conceptual model inside of it. The reasoning portion can be conducted on the synthesis of all of the Bowen literature. So you can take that model that a lot of us well-trained people have in our head and can use to communicate freely between each other in a consistent way, because we have basically the same model. And the LLM can more or less automate the application of the model. That means automate the application of Bowen theory, because it just knows that literature so well and it has it all in its head. Okay? So bringing us back to the app, in the BT Copilot feature, you ask a question you ask a question here. It understands the question. It goes out to the database and looks for passages that are relevant. And then it uses an LLM again to actually spit back an answer and make that answer coherent and make it accurate to the internal reasoning that it did with that literature from the database. That's what's going on here. The key is the LLM. The key is understanding that piece in order to keep moving forward and making this thing better. Because what this is right now is a total Cro-Magnon, Stone Age form of Homo sapiens. What this BT Copilot feature is extremely simple. Just going out and finding an answer from the literature, and only the literature, so it gets that lingo right, is and not the rest of the internet like most models, and then spitting it back in a coherent way is just square one, right? Okay, so that's a lot. That's the first step. That's not enough to move forward. So that's kind of like part one. You might want to take a breather. This is a good resting point, intermission, yada, yada, yada. The key here is the mechanics of how this is built, of how BT Copilot is built using that LLM feature and how it goes out to the database. And the reason that I'm putting this video down is so that a person who doesn't know how to program and make all this stuff can start working out the just the non-technical parts of this to try to get the BT Copilot to work better with the data available in the file. But you got to have a little information about what the building blocks are. So the way that LLM is utilized, when this question comes up, what is a triangle? That is sent to the LLM. That goes to the database, and then there's just a whole bunch of entries that are returned. And that actually, it kind of doesn't use the LLM in a way that we care about. It really just looks for similarities between the words, what is a triangle, and then the passages. But then what happens, and this is where it gets really interesting, is the LLM, the passages that are just literally paragraphs of text here are sent to the LLM as a simple English language script. Okay, this is where things really, really get interesting and complicated. That script, and I actually have it, I can share it. I can't remember exactly the wording, but it's just some things I've typed out, okay? It says, I am, well, let's keep this paraphrased. Here is timeline. Let's do this. Data. And then, and this part is drawn from, oops, no, there's no lines in plain text. And then this next part is drawn from the timeline in the diagram file, the family diagram app file. You know, you've got 2000, you've got a date, and then you've got conflict, and then you've got person A, person B, right? And then you've got another line, and this is just plain text like Notepad in Windows, right? You've got 2, 5, 2, 0, 0, 0, distance. Person A, person C, and then 3, 1, 2,000 inside, or let's just, let's say inside person A, person B. So you got this table, and then it says here's timeline data, and then it literally types that part out. It just slaps it right in there from the timeline. This is what my code does. And then it says here are academic excerpts to evaluate the timeline data. Oops. Right. And then it actually literally lists out, the triangle is a blah, 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 blah. And, that's like from Kerr's book, first book, right? And then there's another, and that goes on for a whole paragraph. Just kind of mark these like this. And then there's another one, and it says maturity is ... And then after, so we've got here's timeline data, and then there's some actual data, many, many lines of that. And then here are some academic excerpts to evaluate the timeline data. And then here's the key prompt. It says based only on the timeline data, use the academic excerpts to evaluate, to answer this question. And then, I know this is complicated, and then the question is inserted after that. What, and let's change this, let's make this a little more interesting. What are the key triangles? That question is actually inserted right here. What are the key triangles? So, okay, this is where it all comes together. I know this is a lot. The point of all of this is what's in this box right here. All you're doing is typing all of this out, right? And the code will stitch all this together. It'll actually add in, here's the timeline data, those words, and then it will add the timeline data line by line, just simple text, right? And then it will say, here are the academic excerpts. It'll add those in, and it says, based only on that timeline data, use the academic excerpts to answer this question. So that's kind of a three-part deal. It says, take the Bowen theory database passages and use those. That's the conceptual model. That's Bowen theory. Use those to evaluate the timeline data and answer this question based on that. And you're just typing this out. All of that goes into the LLM. The LLM only does one thing. It just reads that info and makes sense of it. And then it returns a response. in English. And that just goes here. So that's the core of it. That's what's going on under the hood. The key is to figure out what to put in this box, especially this part. Here's the timeline data, to find the right words for that. Find the right words for based only on the timeline data, use the, and then add in the question. It's to format this thing to be as useful as possible, okay? That's in the simplest way to put it. That's the challenge. However, what's really, really cool, and this is where it gets really, really scalable, like you can make this thing really, really, really sophisticated. We don't even know how sophisticated we can make it, is when you can take the output, is where you can actually combine multiple LLM iterations. You can run this whole process here in this box on a small piece of the problem, run it through the LLM, and then run a whole separate one on another piece of the problem, run it through the LLM, and do that like for 3 or 4 different small pieces of the problem. Like, let's say, what are the key triangles here? What do you make sense? Where are the nodal events for indicating an increase in anxiety? What do you think the baseline anxiety is compared to the fluctuations? Where are the fluctuations? You can divide it into all of these pieces, send each to the LLM, and then take the result of each one of those and write a whole separate prompt that combines them. So you can go with an LLM question 1, LLM 2, LLM 3, LLM 4, and then you can take the result of those, what would be just that chat response, and you can combine them all into another prompt, LLM. Like, what do you suggest? How do you summarize all of these 4 responses and produce a course of action, make a suggestion? This is the furthest my thinking has gone, is what are these? You can build these building blocks, you can make as many as you want. And you can just organize the whole thing. And what you're doing is you're modeling Bowen theory. You're breaking down the process of evaluating the family into small pieces, like these chunks here. And then you're stitching it all back together in whatever way it is those are supposed to fit together. What are the nodal events? How can we characterize the baseline level of anxiety? What is the hypothetical baseline configuration in this family? The inside and outside positions of the triangles in this family. How does the baseline configuration change during an acute flare-up of anxiety? All of these things are implied in the Bowen literature. Now is the time, and this is the chance, the first chance, to actually put the rubber on the road and map this stuff out. And that doesn't even have to be changing anything that's in Bowen theory. It's just actually defining it more clearly. What are the pieces of an evaluation? What is Bowen theory? Because now we've got all this literature that will synthesize the model. We can build these building blocks to automate the processing of the data that people are entering in. We can, we could even have the data entry be scripted. You can include LLMs and have a back and forth like that. I'm not sure. We can have a button. Just one button. Instead of actually asking it chat questions, we can just have an evaluate button, eval, and then it runs this whole script, and we show a progress bar because it's going to take a little bit. That's fine, because it's just going to spit out a report based on the data that's in the diagram. So, this isn't going to be as good as, right now, for the foreseeable future, this isn't going to be as good as a well-trained person. I can do better than this, but it is much, much better than anything you can ever Google. And the sky is the limit with how these building blocks are put together. The question is just what do you type it out? I mean, you could write this stuff by hand. You don't have to know how the technology works. You just have to know how these boxes work, and just figure out what should go in the boxes. So that's AI in a nutshell. That's what's going on. That's what everyone is freaking out about, is the LLM has changed everything. And now everyone in the world is pouring trillions of dollars into trying to get the LLMs better, trying to get the knowledge better, but really the boom is how to build applications like this Bowen theory application based on these building blocks. No one knows where the limit is with that. The sky is the limit. And we just know that it's incredibly powerful. And so anyway, that's it. I'm really curious about how to figure out what goes in those boxes, what to build with this kind of thing. And more heads are certainly better than one with that. So thanks a lot.